that allows it to stick, if you will, very weakly to the activated charcoal. However, after it attaches and more of these molecules of gas come in connection to it, together chemiabsorption, and I missed that day of chemistry, but I looked it up, and it's actually a real solid chemical reaction that's stronger than van der Waals, and it basically it's impregnated within the activated charcoal, meaning it's not going anywhere. Charcoal owns that piece of gas, and it's exactly it's done, it's purged. That would explain why those that didn't get changed on a couple slides ago when I said why they're orange, why the patients went to or woke up, had a case of awareness. This is that same graph with the use of activated charcoal filters at different scale. 5 parts per million, the other one is 50 parts per million. The 5 parts is our triggering threshold for the MHS patient, right? You put these on in your time there, you notice instantaneously you have a drop and you're negligible. The report that you read in the study, it's under 1 part per million, okay, at 10 liters per minute, in under a minute. 90 seconds was on one machine, so they say under 90 seconds. You lower your flow at 45 minutes. The reason they lowered it at 45 minutes was because that's how they designed the primary research that they conducted, showing the lowering of the flow initially without the filters and with the filters. They used a flask of olive oil, as we know, to represent that redistribution phase and compartment model. When they lowered the flow to 3 liters, they saw a bump. But that bump in every single gas was still under 1 part per million. Okay? That's pretty profound. They take them off at 90 minutes. And you get the surge, showing that you were showing 2 things. You have bound or prevented the patient from getting a volatile anesthetic under 5 parts per million. That's safe anesthetic if you are susceptible to malignant hyperthermia. But also, when you take them off, you still, in your anesthesia machine, have a reservoir of volatile anesthetic that will surge, that will go up. And so this, to me, I mean, it proves kind of 2 things. Not only the efficacy of these activated charcoal filters, but, wow, these newer machines, they do have, at a low flow, a reservoir that is a potential catastrophic sentinel event. And now that we know this, wow, I don't want to be a part of that. Is it a new standard? Well, it's a recommendation. It's not a standard. And the sake of standard, M-House doesn't also, and M-House definitely recommends them as one of the 4 for your preparation of the anesthesia machine for a malignant hyperthermia susceptible patient. In an acute crisis, do they recommend their use? They do not recommend their use. They do not recommend their use, which is, okay, that's fine. They recommend don't delay the entry, which I cannot disagree with at all. The entry is your cure. However, research shows that length of time exposed to a triggering agent will have a higher incidence of mortality, meaning that the longer that vapor, or should you just continue to give sucks because you want to on a patient, the more you give of either, the worse outcome you're going to have. Another guy I met in, he's a program director of an anesthesia school in Iowa or Indiana, but they had these filters. They used them in an acute crisis. And what he told me was that as soon as they placed them on, they noticed a decrease in the end-tidal CO2. And I asked him if he's going to write it up. And he's like, I don't think so. I'm like, you should write that up. Or I would write that up. You should definitely write that up. And so I think you might be seeing that come forth. But to me, what does that show? It shows that these work in an acute crisis. They're removing the agent, of course. You're having decreased end-tidal CO2, which, when we reflecting back, we're getting rid of that hypermetabolic state. And of course, we're treating with the insulin. But bottom shelf, top shelf, somewhere in the room, and your patient has an episode of malignant hyperthermia, call for help, get the dantrolene in 20 seconds. I mean, I'm clumsy. I'm just going to try to say it a better way. I'm a clumsy individual, and I could put both of these on the inspiratory and expiratory limbs in less than 20 seconds. So while someone's mixing dantrolene, I'm putting these on the inspiratory and expiratory limb, and together, I mean, you're going to just mitigate a bad storm. So to me, I think they would be good. Any questions?